Division with polynomials. A polynomial function of degree n in x is any function that can be written in the following form, where an, this number here, is not 0, and n is some non-negative integer, and each coefficient of the variable x is a real number. So for example, something like p of x is equal to 5x to the third power minus 4x squared plus 7x minus 8 is a polynomial function. So basically, this number here is the degree of the polynomial. The numbers here are called coefficients, and this first number, the number in front of the highest degree term, is the leading coefficient. We are going to be working extensively with polynomial functions in the very near future, and today we're going to focus on dividing these types of functions. So first we'll start with a simple example. We wish to divide the polynomial that you see on top here by the very simple polynomial 5x squared. Now, when you're dividing by a single term polynomial, what you can do in essence is just rewrite this fraction in which each term on top is divided by the term in the bottom. And then from there, we can do simple division. So we can divide the coefficients. 10 divided by 5, we know that this is equal to 2. And then for the powers, when you divide x to the fifth by x to the second, remember you subtract the exponents. And so this first term ends up being 2x to the third power. And then we repeat. And so we have minus 15 divided by 5, we know that is 3. And then here we have x to the fourth divided by x squared. That's x to the 4 minus 2, which is going to end up giving us negative 3x squared. Plus 20 divided by 5, we know that's 4. And then we have x to the 3 minus 2 for this part here. And this ends up being 4x to the 1, which is 4x. And so dividing by a single term, which is called a monomial, is a rather simple process. In our next example, pretty much the same thing. So we are going to rewrite this as 8x cubed y to the fifth over negative 2x squared y. And then we have minus 16x squared y squared over negative 2x squared y. And then we have plus 4x to the fourth y cubed over negative 2x squared y. The process here is identical, so we're just going to first divide the coefficients. So here 8 divided by negative 2 is negative 4. And then we are going to subtract the exponents of x and subtract the exponents of y. And so for the x here, we have x to the 3 minus 2, which is x to the 1. And we have y to the fifth divided by y to the 1, so that's going to be y to the 5 minus 1 is 4. Next, we have negative 16, but divided by negative 2, that's going to end up being positive 8. Notice here that x squared and x squared cancel out completely. And then for the y variable, we have y squared divided by y, which is just y. Next, we have positive 4 divided by negative 2, which is negative 2. X to the fourth divided by x squared is x squared. And y cubed divided by y to the 1 is y squared. And it says to express the answer with positive exponents. Now, this happened naturally, but if any of these exponents had been negative, we would have to rewrite it by putting that in the denominator of the fraction. So here's another example, just like the previous one. In this case, we have 4 terms in the numerator. So we're going to take each one of those 4 terms, and we're going to divide all of them by 4a squared b squared. And then we do the same thing. We're going to divide the numbers. So 10 divided by 4, well, that reduces to 5 halves. A to the 4th divided by a to the 2nd will be a squared. And then b squared cancels out. Next, we have positive 8 divided by 4, which is positive 2. And here you can see you have a to the 1 divided by a to the 2. So that's going to be a to the 1 minus 2. And then b to the 3 minus 2, of course, that's just going to be 1. But right here, 1 minus 2, which comes from this exponent minus this exponent, this is negative 1. So let's go ahead and change that to a to the negative 1 power. So we're going to have to rewrite that in the end. Then we have negative 12 divided by 4, which is negative 3. And then a cubed divided by a squared is a to the 1. And then b to the 1 divided by b to the 2 is b to the negative 1. Plus, finally, 6 divided by 4 reduces to 3 over 2. And then a to the 1 divided by a to the 2 is a to the negative 1. And then we also have b to the negative 1. From there, we just need to rewrite our answer. So I can write this as 5a squared over 2 plus 2b, and then the a to the negative 1 is just going to drop to the denominator and become a to the positive 1. Same thing happens in the next term, except now the b drops to the bottom. And in the final term, both the a and the b drop to the denominator, making the exponents positive. And so this would be our final answer here. Now, how about a case where we're dividing by 2 terms? So you can see now we're no longer dividing by a monomial. We now have a binomial, right? X plus y is 2 terms. So when this happens, there's 2 different things you can do. One is we could try to factor the numerator. Okay, now this might work, it might not work. So let's check it out. We have x squared minus 6xy minus 7y squared. Let's play around with factoring to see if we can figure this out. X squared we know comes from x times x. Now 7y squared would have to come from 7y multiplied by y, right? Because 7 is prime, so the only way we can get that is 7 times 1. And then to try to make the negative 6xy in the middle, let me try putting a negative here and a positive there. And if you want, go ahead and pause the video and multiply this out and verify that this does indeed give you what you started with. So that means that the original problem can now be rewritten as x minus 7y times x plus y, that's the numerator, and then divided by x plus y in the denominator. And of course, the thing to notice here is that you have a common factor which can be canceled out. Okay, so in this case, we get the answer fairly easily. But what if this did not factor? Or what if it did factor, but the factor here did not match the factor in the denominator? So in these instances, we need a different method. And so now we need to review long division. So to review long division, let's consider a numerical example. Suppose I wish to divide the number 25 into the number 4,628. Now let's recall how this works. So the first thing we do is we ask ourselves, does 25 go into the first digit here? Does 25 go into 4 evenly? And of course the answer is no. So since 25 does not go into 4, we add the next digit to it. Does 25 go into 46? Yes, it does. It goes into it 1 time. And if I multiply 1 times 25, we get 25. And then I'm going to subtract 25 from 46, which is going to give us 21. Now, if we've done this correctly, 25 will not go into 21. So we need to bring down the digit from up there and now ask, how many times does 25 go into the number 212? And the correct answer here is 8 times. And this is because 8 multiplied by 25 is equal to 200. And now if I subtract that, I get 12. Once again, 25 does not go into 12. So we then bring down the next digit, 8. And we do it one more time. How many times does 25 go into 128? Well, it goes in 5 times because 5 multiplied by 25 is 125. Okay, so now this is pretty much the end of the problem. There's a few different ways we can give the answer. So one way to say the answer is 25 goes into 4,628 185 times with a remainder of 3 left over, right? So this is one way we can answer the question. Another way to give the answer to this question is we can say it went in there 185 times plus the remainder of 3, which is over our original divisor of 25. So we can write it like this. So it's 185 and 3/25. This is how you write it as a mixed number. And then the final way we can do it, which I won't do here because it's not relevant to polynomials, but what you could do is you could add a decimal point and a 0, and you could drop that 0 down, and then ask how many times does 25 go into 30, and you would continue until your decimal either stops or repeats. So I won't bother showing that part, but the way we're going to do our answers for polynomials is like this. So let's take a look at an example of dividing polynomials using long division. Suppose we want to divide the polynomial 2x squared minus 7x plus 9 by x minus 2. So the x minus 2 goes outside of the long division symbol. Now to do this, we just focus on the first term here and the first term here. And we're going to ask the question, how many times does x go into 2x squared? So we are taking 2x squared and dividing it by x, which of course gives us 2x. So x goes into 2x squared 2x times. Now from there, we're going to multiply 2x by x minus 2. So 2x times x is 2x squared. And 2x times negative 2 is negative 4x. Now remember what we did next. We have to subtract, which means we're going to subtract this, and we're going to subtract this, which turns that into a plus sign. If you do the subtraction, notice that these cancel out. Negative 7x plus 4x is negative 3x. And then the plus 9 is going to come down. And now we repeat the process. So now we're just going to refocus on the first term here, which is x, and the first term here, which is negative 3x. So if I take negative 3x and I divide it by x, this is going to give us negative 3. So x goes into negative 3x negative 3 times. Now we're going to multiply negative 3 times x, which is negative 3x, and negative 3 times negative 2, which is positive 6. Notice that I did not put the plus sign. That's because we still have to subtract this and subtract this. So when we subtract here, that becomes a plus, and when we subtract here, that's going to become a minus. Finally, 9 take away 6 here is 3, and that is our remainder. So the answer is this part, right, which is called your quotient. That's the main part of your answer. So it's going to be 2x minus 3 plus your remainder, which is this part here, which is 3, divided by your divisor, which is this part here, which is x minus 2. And so the answer is 2x minus 3 plus 3 over x minus 2. And you'll notice that it did not divide evenly, right? If the remainder is 0, it divides evenly and you wouldn't have this part. But since you had a non-zero remainder, we know that x minus 2 does not go into 2x squared minus 7x plus 9 evenly. In our next example, it's pretty much the same thing. I do want to point out, though, that you do have a power of x missing here. So you have 4x cubed. And then notice that there is no x squared there. I'm going to represent that. So I'm going to put in a 0x squared there, and then minus 6x, and then minus 11. So anytime you're missing a power of x, you want to be sure that you put in that missing power as kind of a placeholder. So now let's do the long division. We have 4x cubed is being divided by 2x. And that's going to be 2x squared, right? So 2x goes into 4x cubed, 2x squared times 2x is 4x cubed. And 2x squared times negative 4 is negative 8x squared. And you can see that's why you want to have that placeholder there. So you have something to line it up with, because whatever you line it up with, they need to be like terms. Don't forget you have to subtract both of those. These cancel out. We're going to have positive 8x squared, and the next two terms we're just going to bring down. And now we repeat. So the next step, we take 8x squared, and we're going to divide it by 2x. So 8x squared divided by 2x is 4x, positive 4x. So that we're saying that 2x goes into 8x squared, positive 4x times. And this is because positive 4x times positive 2x is positive 8x squared. Positive 4x times negative 4 is negative 16x. And then we have to subtract. Combine here, we get 10x minus 11. We have to do this one more time. So now we're taking 10x and dividing it by 2x, which is 5, positive 5. So 2x goes into 10x positive 5 times. 5 times 2x is 10x. And 5 times negative 4 is negative 20. Subtract, subtract. Combine, we get 9. And so the answer here is 2x squared plus 4x plus 5 plus the remainder, which is 9, over the divisor, which is 2x minus 4. Now you can use long division to divide with multiple variables. It can be a little bit tricky, and I don't recommend doing this all the time, but I'll go ahead and show you this example where it does work quite well. So again, you just focus on leading terms. So how many times does x go into x squared? Well, that goes in there x times, because x times x is x squared. And x times y is xy. Don't forget you have to subtract each one of those. So first terms cancel. We have negative 7xy minus 7x squared. How many times does x go into negative 7xy? Well, it goes in there negative 7y times, because negative 7y times x is negative 7xy. And negative 7y times y is negative 7y squared. Oops, sorry. This should be a y squared here. I wrote that down incorrectly. There we go. And this should be a y squared. Now when I subtract those, notice that everything cancels and we get 0. And so the answer here is simply x minus 7y, and there is no remainder. The good thing about long division is that we can use it to factor polynomials. Suppose we have a polynomial x cubed plus 9x squared plus 26x plus 24. And let's suppose we know for some reason that x plus 2 is one of its factors. We can use that fact to help us completely factor this polynomial. So just keep in mind that if I had told you to factor the polynomial x cubed plus 9x squared plus 26x plus 24, this would be difficult, right? Because it's not a trinomial. You can't use grouping. This is difficult to factor. However, if I know that x plus 2 is one of its factors, I can use long division to divide x plus 2 into the polynomial. And since I know it's one of its factors, I know the remainder should be equal to 0. So let's go ahead and do the long division and see what we get. So again, x goes into x cubed, x squared times. X squared times x is x cubed. And x squared times 2 is 2x squared. Don't forget you have to subtract both of those. Combining like terms, we get 7x squared. And then these other two terms we'll just bring down. Now let's repeat. X goes into 7x squared, positive 7x times. 7x times x is 7x squared. 7x times 2 is 14x, positive 14x. Now again, notice I don't put the plus sign. That's because I know I'm about to subtract. And it just looks better if you don't put the plus sign. What we have left here is 12x plus 24. But x goes into 12x, positive 12 times. And 12 times x is 12x. And 12 times 2 is positive 24. Whoops, positive 24. I'm going to not put the plus sign because we have to subtract. And just like we expected, the remainder is 0, which basically just means they told us the truth, right? They told us it was one of the factors, and if you have a factor, your remainder should be 0. But what does this mean exactly? Well, it means the original polynomial here is equal to x plus 2 multiplied by x squared plus 7x plus 12, right? Because we know that this times this must be equal to this when our remainder is 0. But if you look at this one here is very simple to factor. We know that x squared plus 7x plus 12 can be factored into x plus 3 times x plus 4. And if you notice now, we have completely factored the original polynomial. So here's the thing to keep in mind. We don't just use long division to do division. We use long division to help us factor. So if only there was a better way to do division, right? Because this is not a very fun procedure. So now we are going to talk about an easier way to do division. And this is called synthetic division. So let's suppose I wanted to divide this polynomial, which is a pretty big polynomial, by x minus 2. So this synthetic division will work if we are dividing by x plus some number or x minus some number. And it doesn't matter what you call this number. I'm calling it r, but you can call it anything. So in this case, I am dividing by x minus 2. So here's how the procedure works. And this part you just need to get comfortable with. For the part that you're dividing by, in this case, x minus 2, what you're going to do is take the opposite of the number you see here and put that number in this box. So I see a negative 2 here, right? I'm going to put a positive 2 in the box. Now for the other polynomial, the one that you're dividing, right, this one here, look at all your coefficients. You have a 1 coefficient here, then you have a negative 2, and then a positive 4, and then a negative 6, and a positive 2. And notice how there are no missing powers, right? You have x to the 4th, x to the 3rd, x to the 2nd, x to the 1st, and a constant term. So what I'm going to do is take all of those coefficients, and I'm just going to write them in order right here, and leave a little bit of space in between. So we have 1x to the 4th, negative 2x cubed, positive 4x squared, negative 6x, and positive 2. And the beauty here is I don't have to put down the variables, just the coefficients. Now here's how the process works. The first coefficient, the leading coefficient, this one here, is just going to come down. And this is the setup. Okay? Now for the procedure. Here's the procedure. We are going to multiply the number in the box by the number down here. So 2 multiplied to 1 is equal to 2. And we're going to put the answer right here. So again, 2 times 1 is 2. And then we are going to add these numbers together. Negative 2 plus 2 is 0. And then we repeat that process. Now we take 2 here and multiply it by 0. 2 multiplied by 0 is 0. And then we add these numbers together to get 4. Multiply again. 2 times 4 is 8. Add these numbers together, we get 2. And finally, 2 multiplied by 2 is 4. Add these numbers together, and we get 6. And this is your answer. This part right here represents the quotient, and this represents the remainder. Now, of course, we're not going to write our answer like that. Just like these numbers represented the polynomial up here that you started with, these numbers are going to represent your answer. And the answer is going to be 1 degree less than what you started with. So our answer is going to be 1x cubed plus 0x squared plus 4x plus 2 plus our remainder is 6, and that goes over our original divisor, which was x minus 2. And then, of course, in the end, we can write it without this term, right? We can leave this term out. And this is the synthetic division process. Now, I promise you, once you get used to this, you will never want to use long division again. So let's try one more. We're going to divide 3x cubed minus 4x plus 5 by x plus 4. So first thing I'm going to remember is that if I'm dividing by x plus 4, when I make my little box here, I have to put negative 4 in the box. And actually, let me do it in blue here. There we go. Now for the polynomial we're dividing, we have 3x cubed. Notice we have 0x squared, and then minus 4x, and then plus 5. We need all of those numbers. So 3x cubed, 0x squared, very important, and then negative 4x, and then positive 5. And now the procedure is the same. So again, here's our setup. Now for the procedure, we multiply negative 4 times 3, which is negative 12. We add these numbers, which gives us negative 12. Negative 4 times negative 12 is positive 48. Add these numbers together, we get 44. Now we have negative 4 times 44, which is negative 176. And then adding these numbers together gives us negative 171. So here is our answer, right? That's our quotient, and this is our remainder. So our answer is going to be 3x squared minus 12x plus 44 minus 171 over x plus 4. And that concludes this video lesson.